recording. So recording is started, right?
Yes.
Okay. Okay, so we covered the matrix operation. So how to create 1D, 2D arrays, because matrices are nothing but 2D arrays, right? So how we can create matrices using NumPy. So those things we have covered. So, in Python, we do not require, at least for data science works, we do not require matrices as much, because all the things we can do, in fact, if not all, but most of the things we can do using data frames. So matrix, unlike C++, or even in R also we use matrix, but Python we do not require to operate on matrices that much. If sometimes we need to uh, find, say, diagonal values or trace or singular values, those things sometimes we need, but most of these things can be performed on data frame. So data frame is much more generalized concept than matrix. So we do not require matrix that much, but uh, if sometimes you require to create a matrix, so this is the way you can use NumPy array to create matrix. Okay, so in today's session, we'll start with conditional statements. So most of these things we already know. That's why like we will do a brush up on the concepts. So in Python, we have different types of conditional statements, but all these conditional statements has the root in if-else conditions, right? So the if conditions, uh, if block followed by else if. Uh, so in Python we tell it as elif, right? So these blocks we can use. So if else the conditional blocks in Python, right? So we'll see some quick programs here. Nothing to these are very simple things just to brush up the concepts. So this is how we write the if else block. So here we are checking. This is a very simple thing. Here we are checking if a given integer is negative or non-negative, right? So suppose we give some number, so then we can check. So it is a non-negative number if we give -2. So it is a negative number. If we give 0, then it is a non-negative number, right? So now another program to check if a number is multiple of 2. Here what we are doing, so first we are creating a number dictionary. Now uh, some things, so these are some of the very small things but very useful. And you can split a Jupyter cell by pressing where you want to split. So you can split a Jupyter cell by pressing this is the shortcut, control shift minus. Suppose I want to split it here, and control shift minus. Then if you want to split it here, control shift minus. And then for joining multiple cells, the shortcut is shift M. You can join the cells. So now, okay, so there are some okay, so we are discussing here, so I will share this with you. So the Python handouts, so these are some quick shortcuts for working in Jupyter notebooks, right? So how to do the different things.
Okay.
This is very handy when you are writing a program. So this small things you do not need to worry. Right? So for splitting cell, control shift minus. For merging cell, shift M. Then if you want to have a cell below, then you need to press B. If you want to have a cell above, then you need to press A. Right? If you want to delete multiple cell, then you need to select shift, then up or down key, and then DD. Double D will delete the selected cells. Right? So here we are creating a number dictionary. right? So let us see what we have created. So we have created a dictionary, right, 1 to 25. So this from keys range 1 to 26, right, and then none. So from keys, this is a function, right? So basically it is a dictionary method. It is nothing but function only, but when something appears after dot, so that means this particular function is applicable to that particular data type or object. So these are known as methods. So from keys, you can say that it is a method of dictionary. So if the method is not allowable, then you cannot apply. So from keys is an available method of dictionary. So if you create a dictionary, then type dot. Then if you type tab, then you can see all the available methods, means the things what you can apply. So I actually all like the key value pairs description, right? And if you want to see the help, then you can do it like that. Shift tab, right? So numdex, then item. Suppose you want to see what it means, like what is its syntax, then you can do it like that. So yeah, we have created from keys, right? So shift tab, so it will give you the help on this. So it's these things are very simple to get the helps and to get the code completion hint. So these things are like very simple in Python. So create a from cases, create a new dictionary with keys from iterable and values set to so iterable value equal to none. So what it did, so I have given range from 1 to 26. That means it will iterate from 1 to 25. In Python, if you give the range till 1 to n, then it will iterate till 1 to n minus 1. It will create a list of items from 1 to n minus 1. So it created a dictionary with keys from this first argument, and then all the values are set as none. So this is nothing but like that from case, it creates a dictionary and initializes. So I had created a dictionary and initializes the values as none. So you can do it like if you want, so any value you can give. So if I give 0, then it will create the dictionary and initialize the keys at value 0. So this is one line command for creating as well as initializing.
Okay.
Yeah. So now okay. So now this printing is done. Now to check if each number is a multiple of 2 or 2 multiple of 2, 3, right? So here we have 25 numbers, right? This is our input. Now to check if each number is multiple of 2. So how to do that? So this is the operator. So each number, so we are now iterating through a for loop. So each number in num dictionary. So another thing to notice here, when you iterate over a dictionary, then it will always iterate over the keys of the dictionary. Okay, so we do not need to write like that from this and then keys. That is not needed, right? Num dictionary is the dictionary we created above, right? This is the
Yes.
dictionary. Now, when you write for number in num dictionary, then no need to give keys because it itself means that it will iterate over the keys of the dictionary, right? Then what we are checking, so this is, as you know, this is the remainder operator. Percentage is the remainder operator. This is a math operator. I will share this also, the handout. So Python operators. So just you can have a look. So these are different operators, right? So this is modulus operator. It will give the remainder. To divide a number by another number, then what will be the remainder? So it will give the remainder. Right? Star star gives the exponent.
Yeah.
So if the remainder is divisible by 2, that means now if the number is divisible by 2, then that means that it is an even number. Then again we are checking. So we can have nested if blocks in Python as in other language. So if it is divisible by 2, then we are going to the nested block. If it is again divisible by 3, then we are displaying the number is divisible by both 2 and 3. Else else means the number is only divisible by 2, but this else is connected with this inside if, right? So else the number is divisible by only by 2 but not by 3. Similarly, now this else so let me do another thing. So
I'm able to understand.
yeah.
Okay.
Yeah, so I'm inserted line number also for easy understanding. So then it will display this. If it is we are doing division by 3. Now you can see that for each number, it uh, so these are the dictionary keys. Then it is checking the divisibility, right? So this is clear and simple. So
Yes.
here I inserted the cell numbers. So you can insert the cell numbers from here, toggle line numbers, right? Now, similarly, to check if each number is a multiple of 2 and 3, so we can do that. Then some other things, check if a given number contains a square or not, right? So, uh, contains any square number, right? So, here, these are some of the concepts of if condition. So, here, this is a number. I want to check if this number contains any square digit, right? So it contains square digit because 1 is a square digit, right? So what I have done, so round np square root of this. So np dot square root, so square root is an object method of NumPy. Uh, so np dot square root of integer x. So this if equal to np dot square root integer x, right? For x in list of string number. So here my number is given. So list of string number, it will give uh, the values of the string, the digits of the string as numbers, right? So now what I am doing, I am checking if this digit, any of this digit is square number. Now, so these things are pretty much simple. Now, just one more thing. So in Python, we can use one line statement like if else statement. So that is known as conditional statement, and we can assign also. So this example gives the does the conditional assignment. So let us see what it does. So here number equal to 2. So result true if number less than 5, else false. So it will do the conditional assignment, right? So in one line itself, you can do the assignment.
Okay.
So true if this less than 5, else false. So these are very simple things, but in large programs, when you are building a large module, then this comes as very handy, right? So this is known as conditional assignment, right?
Yeah.
So this example is again similar. So we are creating a number dictionary from keys, right? So 1 to 40, and then we are checking square number, right? So how we are checking the square number? So it is similar to the previous example, the first example. We are finding the square root of number, and we are checking after rounding if it is same. So some conceptual thing here. Suppose we take a number, say number equal to 20, right? And we find np square root of number. So here what we are doing, we are checking if the number is a square number. So a quick method is to check like that. So here we can see that the square root of number, of course 20 is not a square number, right? So now if we so round it, so what will happen? So again, whenever you need to find a help about anything, so shift tab. So round number and digits. So round is a function. It is an inbuilt function of Python. So it rounds a number. So here you can give the digits till how many digits you need to round. If digits is none, then it will remove the decimal places. So suppose I want to round it till 2 decimal places, then it will round. If I do not give anything, then what it will do, it will remove the decimal places, right? So this will be simply a float number, right?
Yeah.
So now, what does it mean? So let us check this one. Round np square root of number if it is equal to np square root of number, right? So let us check. It came as false. Why? So check this. After rounding, it came as 4.0, and without rounding, it is this number, right? So of course, these two are not same. So the trick here is that, but if it were a square number, then what would have happened? So this is true, right? So I have taken number equal to 25. Then you can see that rounding, I have not given any digits. Round takes two arguments. I have not given any digits, right? So that means it rounded the number till the uh, all the decimal places have been removed except the first decimal place. And if we take simply the np square root, then also it comes at 5.0 because 25 is a square number. So if the two are same, that means that the number is a square number. Got it?
Yes.
So this is the trick used here, right? If after rounding, if it is same as the number, then it is square number. After rounding the square root, right? So these are some quick
1 second.
so these are some quick examples of conditional statements. Then like we can try to loop concept.
Yeah.
Okay. So in Python, as you know, there are uh, two kinds of loops. So for loop and while loop, right? So the loops in Python are very powerful. So we can use the loop concept like wherever needed. So we can use because loop is like it is in the generics of genome of Python. We need to use loop many times. Without loop, we can't do anything, right? So some of the examples. So this is how we write the Python loops. As you know, in Python, we do not give any brackets, because Python is a very open structured programming language. So it is very minimalistic things we need to do. We do not need to give any square brackets at all, but we need to keep in mind about the indenting, right? So the correct indenting we need to give. So when we write a then inside the block, so we need to give the body of the block. All the whole body of the block should be under one indenting, right? So indenting, through the indenting, we understand which part falls inside which part. So this is the structure of false loop. So what we are going to do here. So again, we have taken we have defined this one. So I'll explain one by one. uh, Sometimes the things are simple, but still need to know them. So in Python, another beautiful thing with Python is that we can do the multiple assignments in one line, right? So see, digits and cube digits. So two assignments I have done here. So digits is nothing but a range. So range 1 to 31, comma 2. 2 means the step size, right? And then cube digits is a uh, empty dictionary, right? So in Python, we can do the assignments like that. Suppose A, B is 2, 3, right? A, B, C
Yes.
is 2, 3, 4. I think you know that, right? So
Yes.
yeah, so then we can see the values. So in one line itself, we can do the assignment. So here my digits check. So my digits which I defined. So step size is 2. So 1 to 29, right? So now I want to check which are the cube digits, right? So means I want to find the cubes of each of the digits. So for I n digits, what I am doing, so see, cube digits I have defined as an empty dictionary. Now I am updating the dictionary. So this dictionary dot update. So as you discussed in the last class, so we can use the update, and then here, so while updating a dictionary, after creating a dictionary, if you want to update a dictionary, so you can do like that. Cube digits dot update means dictionary dot update, and then you can give the new value of the particular key. So I am updating each of the key. Right? So it displays the cubes of each of the values. Now, so please let me know if you have any query.
Yes.
So here what we are doing, we are finding sum of natural numbers, right? So natural number, the value of n means the range. So I want to find the sum of all natural numbers till num, right? So num 30. So sum value and I define. So sum value is 0 and I is 1. So now here I am using while loop. While I less than equal to number, so then uh, what I'm doing, so if I is divisible by 3, then sum value plus I, right? And then I'm incrementing the value of I. So this sum is 165. So while my I is less than equal to number, so then I'm taking the sum. So in this way, we can find the sum of, so here what, can you tell me what we have done? This way I have used this if condition, what actually it found? If I remove this condition, then what would have happened? So this is 465. I have removed the if condition. So it found the sum of all numbers from 1 to 30, right?
Yeah.
So if I give say 10, so it will find sum of all numbers from 1 to 10. But uh, here my intention was different. So here my intention was to find all the numbers, uh, sum of all those numbers which are divisible by 3 from between 1 to 30. So that's why I used the if condition, right? If I modulus 3 equal to 0, then only we are adding, right?
Yeah.
Then another example, but this is similar to that. So here, this part, see, right? So again, we have defined the digits, right, in this previous manner. So digits will be, I have given range 131, 2. So this will be digits, cell number 112, right? So now, so I'm finding the cubes of the digits, right? So cube digits I'm finding like that. So uh, I'm finding the cubes of the digits and updating the dictionary. So that we have did in the previous example also in a different manner. So using for loop. So remember, I have used the for loop for finding the cube of the digits, but the same thing I can do using the while loop also. Okay. So now uh, another example. This is important. So in loop, so I think you know we can use the break statement. Break and pass are two statements in Python,
Mm.
right? So break, when to use break statement. So please listen it carefully. So break statement is used because many times I have seen even seasoned programmer also, they sometimes get confused while using break statement. So what is the purpose of break? So break can be only used, break and pass, they can be only used inside a loop, right? So these two statements, break and pass. So these two statements can be only,
Continue is also there.
yeah, break, pass, and continue. Sorry, break and continue. Continue is actually for pass. In R we name it as pass, but Python we call it continue. Right? Okay. So these two statements we use only inside a loop. So when we apply break inside a loop, then what it does? It breaks from the innermost loop. So the point to be noted here is that it breaks from the innermost loop. We can have a series of nested loops. So, but when we apply break, then it will come innermost loop, right? But the other loops will still continue, right?
Yeah.
So it is not like that. By applying break, sometimes people misinterpret it. They think that okay, if I apply break, then it will come out of the whole loop structure, but not like that. If suppose you are using three nested loops, then and inside the innermost loop you applied break at some place, then it will only come out of the innermost loop. Right?
Yeah.
So this is the purpose of break. What is the purpose of continue? So breaks point where you applied the statement. Continue, what it does. So continue is sort of opposite of break. So it it just ignores the current iteration and goes to the continues with the remaining iterations. I'll explain through an example. So this is the purpose of. So let us see here the usefulness of break. Our aim here is to find Armstrong numbers. So this is a very important concept in mathematics. So Armstrong numbers are those numbers where if we find the cubes of the digits of the number and sum them, then it will be the sum will be equal to the value of the number. I mean to say, suppose you take a number say 1, 2, 3, right? Then if you find uh, this thing 1 cube plus 2 cube plus 3 cube, right? And if it comes to be equal to itself, that particular number is known as Armstrong numbers, right? So 1 to 3 is not an Armstrong number because 1 cube is 1, 2 cube is 8, and 3 cube is 27, right? So 28 plus 8, that is 36, that is not equal to 1, 2, 3. So this is not an Armstrong number. But if it were equal to the number, then this is known as an Armstrong number. So our intention here is to find the Armstrong numbers, right? So yeah. So what we are doing, so here we initialized first a count, and so count is nothing but to count the uh, that to maintain a track of the loop and I, right? So now here we are using while true. So we can use true also. While loop starts with a condition, right? So in place of condition, suppose we are not sure about the exact condition, then we can start the loop. This is known as infinite loop. So we can start the loop with a true condition. So true will always evaluate to true. So, but remember one thing, if we are using true as the condition in a while loop, then we must need to use break at some point, right? Otherwise the loop will be an infinite loop.
Yeah.
But this while true statement is useful, suppose you are not sure what is your exact condition of breaking the loop or loop ending. So suppose you are not sure upfront, in that case you can use while true, and wherever your condition is satisfied, then you can break the loop.
Okay.
So what I am doing here, So temp order sum value. So I, length of string I, right? So my first I equal to 1. So length of string I and 0. Now while my temp is greater than 0, so digit equal to temp by temp modulus 10. And then sum value we are adding. So thing is very simple. Sum value plus is digit, then power of order, right? So order is nothing but length of string, right? So what I am doing, I am fetching each digit, right? Each digit from the number.
Yeah.
So suppose my number is 1, 2, 3, then what I am doing at each time, I am finding its remainder by 10. So 1, 2, 3, if I find the first remainder, so this is modulus operator. So if I find the first remainder, so that will be 3. Then after that, second remainder 2 and 1. So I am extracting the digits. Then what I am doing, I am taking the power of the digits by the order. So order is nothing but length of the string. So here, so Armstrong number is like that. So suppose we have a number 1534. 1534. Then the order of the number is length of the string 1534, right? So that is 4. So the number will be an Armstrong number if the power of the digits by the power should be the length of the digit, right? So length of this number is 4. So if I take the same power, means fourth power of each of the digits and sum them, and if we get the same number, then it will be an Armstrong number. So that is what I am doing. I'm extracting the digits, and then I'm, so order is nothing but length of the string, and I'm taking the same power.
Yeah.
Then this if condition, so if order is greater than equal to 2 and I is equal to some value, so I is my number, right? So I is my original number. So if it is equal to the sum value, then sum of the digits by taking that order, then it is an Armstrong number. So now I ran it. So here I have used the break condition. So my intention here is to find the first 10 Armstrong numbers, right?
Yeah.
So that's why, see, I started with an infinite while loop, and when my counter becomes 10, so I'm increasing the count. So whenever I found an Armstrong number, so see this if condition, line number 10 to 12, if my I is my original number, right? I am increasing I also. So I started from I equal to 1, and then I'm, because I do not know which number will be Armstrong number, right? Here this is because this is not a straightforward finding. So at what position I will get an Armstrong number? You can see that the first Armstrong number is 153. You can check 1 cube plus 5 cube plus 3 cube equal to 153, right? You can check that. The second Armstrong number is 370. 3 cube plus 7 cube equal to plus 0 cube, of course that is 0. 3 cube plus 7 cube equal to 370, right? So the catch here is that I do not know at what position I will get my Armstrong numbers. So that's why I have maintained two loop counters. One is the number itself, number I will get on increasing, I will start with 1 and then I will get on increasing, right? And counter also I will get on increasing, right? So whenever I get an Armstrong number, then only I am increasing my counter, this count, and I go on increasing. So increasing after each iteration, right? So when my count becomes 10, that means here the ask is to find the first 10 Armstrong numbers. So whenever my count becomes 10, then I am breaking out of the loop. Okay. So these are my first 10 Armstrong numbers. It took some time because the loop needs to traverse a lot of numbers. Right?
Yeah.
So this is clear, right? The usefulness of break here. We'll see more examples. These two examples. So these are very important. Almost in all programming, so we use this example. So to check if a given number is prime number, right? So again, uh, the concept of break we will use. So as you know, a number is prime if it is only divisible by 1 and by itself.
So, yeah.
Right? So this is its basic definition of prime number. But if we use that for that definition, then the code will be, the time complexity of the code will increase a lot. So another thing is that, another definition is that a number is a prime number if it is divisible by, if a number is a prime number if it is not divisible by any prime which is less than equal to the square root of the number. Right? So suppose we take say 37, right? So we take np dot 37 and take int. So see, np dot square root of 37, that will be a decimal number. So I have taken int before that, and I just need the integer part. So this is known as typecasting in Python. This concept is known as typecasting. So we can change the type, right? Here np sqrt, it will give you the square root in decimals, and then if we apply int, so it will typecast the decimal to integer, right? So 37, how to decide 37 is a prime? So if we check with all the primes below 6, means less than 6, so all the primes less than 6 are 2, 3 and 5. So we can divide 37 by 2, 3 and 5 repeatedly. If none of them divide the number, that is 37, then it will be prime. Okay, so this concept is, hello, you are able to hear me?
Yes, yes, yes.
Okay, so see, otherwise what we need to do, we need to check all the numbers, all these numbers. We need to divide and check all these numbers, right?
Yes.
But that is not required. Sorry, 0 will not be there. So see, this is not required because one thing is that this, like dividing and checking by all this number will be like time complexity will increase a lot.
Yes.
So this concept is used here. So I have taken a number, and then if number is greater than 1, then I am running a for loop from this particular number till range 2 to int this star star. So in Python, as you know, star star is for getting the power of the number, right? And we can use it for finding the decimal powers also. So here, a number to the power 0.5, of course, it means the square root of the number, right? Right. So suppose 25, to find, there is np dot sqrt also, but we can simply find power root like that, right? And we can also use np dot sqrt. So similarly, similarly, suppose you want to find the cube root of a number. So cube root will be, as you know, 1 by 3, right? So we can use like that. So all these are very simple. So I'm running the loop from 2 to square root of the number plus 1. So then if number is divisible by any of them, right, then it is not prime. Not prime, and then no need of checking, right? We can just break out of the loop, because this range is from 2 till square root of the number plus 1, right? So suppose if I take some number, say 91, right? So 91, square root of the number is 9, so all the prime inside 9 are 2, 3, 5 and 7, right? So you can see that 91 is not a prime number because 91 is 7 into 13, so 7 will divide it, right? So if at any point the number gets divided by a number, this whole number, that is num, gets divided by any of the number, then of course it is not prime, right? So then we are just coming out of the loop. So I have used the break statement here. But if not, then that means it will exhaust the entire loop, right? So I have exhausted my entire loop and still the number is not prime. So suppose 97, right? 97 is a prime number. So in 97 also, in case of 97 also, I will check by 2, 3, 5, 7. But in all the cases, it is not divisible. So the break condition, that break statement didn't come into picture, so it is a prime number. So this is how we can check. So 91 is not a prime, and it is also giving the factors of 91 due to this statement. This is not a prime, and factors are the number uh, equal to number this I, and then number this floor division. This is known as floor division I. Okay. And in Python, so this, do you know this format statement when we print something? So format statement comes into picture. So we can give at the time of printing, suppose I want to print something, right? So, and I need to give the customized values at some places, right? So we can use the format statement
Yes.
to say this 22, then 11, then 2, right? So I'm just explaining wherever the things are coming, right? Whatever things is coming into a place. So here, see 0. So this will, while writing a print statement, if you give bracket and 0, then first 0 will be replaced by this 0, right? Inside format. And then 1. So we need to give a curly brace and write the appropriate index. So this 1 will be replaced by format 1, means the value at the index 1, and 2 will be replaced by value at index 2, right?
Yes.
Okay, so I guess this part is clear, right?
Yes.
Similarly, we can use the same concept to find total all the prime numbers in a given range, right? So for the same concept here, what we are doing, so here we are applying the same concept of prime number, and if it is prime, then we are displaying it. Otherwise, if it is not prime, then we are not doing that. So here you can see the two break statement there. First one is for checking if the number is prime. Second one, second break is if total primes. So here the what we are going to do, we are going to find the first 100 prime numbers. So if my number of prime numbers, I have again taken a considered a count statement, count object. So if my count is equal to total primes, then I am breaking out of the loop. So this code finds the uh, first 100 prime numbers. Similarly, I can use this code to find any number of prime numbers, right? So suppose I want to find first 10 prime numbers, then it will find the first 10 prime numbers. So first break, this break is for checking prime number as before, as I explained before, this concept is used. Second break is to break when I reach the required number of prime numbers.
Got it.
Okay, so now Python pass statement. So this is it's simple, but we need to check what is happening. So as we are discussing, so uh, pass means passing a loop, right? So yeah, so I was explaining. So in Python, as I was telling, in R it is continue. In Python, the statement is actually pass. This is the keyword. Okay.
But I mean, generally, if we see, they will give three keywords: break, pass, and continue.
Hmm. But here,
Um,
yeah, here when check, uh, yeah, but here when we are using continue is the keyword, that is right. But here our intention is to use inside a loop, right? So here like this, we need to use pass, means passing the loop, right?
If I'm right, the difference between continue and pass is like if we say, like if suppose if any condition, if condition is not, I mean matching, then pass. That means it will pass that loop. I mean it will not run for that particular condition. It will skip. Same thing for continue.
Yes, yes.
But say in loop, if loop is there, say for I in range 0 to 10
Hmm.
or in range 10, and I say pass, and so it will do nothing.
It will do nothing, right?
But if I say for I in range 10, continue, no,
Then
sorry,
it will skip the, yeah, yeah. So
and
it will
then
skip
I will,
the, it
yeah.
will skip that, it will skip that condition, it will skip that iteration, and then uh, it will go to the next one.
Yeah,
So
so
let us
it
check.
means if I say like if I equals to 2 and pass,
Hmm.
that doesn't mean the loop will stop it. It is same thing, right? Continue and pass. Almost same thing only.
Yes, yes. So see here what is happening. So let us see with an example. So we are checking, right? So again, so if I is divisible by 2, so we need to find the sum of natural numbers, right? So now if I is divisible by 2, then we are not doing anything. We are simply passing it. Means pass means we are not doing anything. So this statement actually here is not like sorry, yes, this here this is given, so let me edit it like that. So here I got the sum as 55, right? So now, okay, so this is the difference. So if I do not give this statement, right, so then I am getting sum as 25. So here what is happening? If I is divisible by 2, then nothing to do, we just pass that particular index, right? We are not adding it.
If instead of pass, if we give continue, same thing will come.
Yeah, so we can
And
check that.
why they give keywords like break, continue, and pass? Like, what is the primary difference?
Yeah, so see, the difference is that so pass is not only so actually, yeah. So we are discussing about pass and continue. So see, pass is not only used inside a loop, right? So suppose break condition means break statement. So break statement, hello,
Yes, yes.
yeah. So break statement you can only use inside a loop. If loop is not there, so you cannot use break statement. So suppose I write something like that. So number, so suppose number is 20. If number say greater than 10, then break.
Pass we can use in functions as well. Like empty function,
Yes,
we can keep and give pass.
right. So this is the difference. So here see, this is a syntactical error. So what happened, I have used break here, but there is no loop, right? So break you cannot use without a loop. Similarly, you cannot use continue without a loop, right? So now if I check,
Comments are not there.
uh, yeah, so the past statement should be like that. So as you have seen, yeah, We are here. Yeah, so suppose the same thing I do like that. I define my number, and then if uh, number greater than 10, then pass, right? It will work. But if I give this break, it will not work. See, the condition is break outside the loop. We need to give this column. If I give continue, it will not work. Continue not properly in loop. So, but if we give pass, so pass will work. So this is the difference. So break and continue, like in other languages, break and continue can only be used. The point to be noted here: break and continue can only be used inside a loop, right?
Yeah.
So as I have shown here, so here the error itself, we did nothing wrong except the fact that break we have used out without a loop. So break outside a loop. Similarly, if we give the continue statement, so continue also we cannot use without a loop, but pass we can use. So the purpose of pass is that simply to do nothing, right? If we want to pass something, so it can be used in a if statement, if block, it can be used inside a function, it can be used any place, right? Suppose you are writing a big chunk of code, and at some place you are evaluating the condition, but you do not want to do anything. This is just a sort of redundant condition, you do not want to do anything. Then in that case you can simply use pass. It is a very handy keyword. So you just need to ignore the condition. You require to check that condition due to the structure of the code, but you don't want to do anything with that condition. In that case you can use pass.
Yeah. Well, constructing abstract method
Yes.
where there is no definition.
Yes. So let us see an example again. So we define say a number, we define like that. So range. So here I am using this condition, right? So I am using a while loop. Just
Hello. Hello.
Hello.
Yeah, I am not able to see screen.
Yeah, yeah. So let me share again.
Yes, now I can see.
You can see. Okay, so I defined numbers, right? So uh, numbers from 1 to 10. Now, so, so this will simply, this is the thing with while loop. We need to give the increment appropriately. Right? So here I am just printing. You are able to see the screen.
Yes, yes, I am able to see.
Yeah. So now he right. So we need to, like, this kind of silly mistakes often happen. So we need to give the increment properly if we are using a while loop, right? So because in for loop, increment, like initialization, condition checking, and increment, all these three parts occur in the loop statement itself, right? With while loop, so if we miss the increment, because while is like for is this is a combined statement for loop, but in case of while, the loop parts, that is loop initialization, loop counter initialization, then loop statement and loop body, they are uh, performed separately, right? So now let us check what happens. 6. So it will print till 6. Then if I use pass, then what will happen? It will do nothing, right? Just see the differences. In first one, I used break, right? So break means here, like, I'm doing nothing. I'm just printing, right? I'm executing a loop. I define the numbers from 1 to 10 and executing a loop which just prints the numbers. Now, if I give break, then when I reaches uh, at 6, then it will simply break and come out of the loop, right?
Yes.
If I give pass, then what will happen? So it will do nothing. printing will still continue because that print statement is before that, right? So printing will still continue. It will do the printing. It will do nothing, right? So if my print statement was here, so then also like it will do nothing. Now if I give the continue statement, then what will happen?
Only sixth. Only if I equals to 6 part will skip. Other than that, everything will print.
Yes.
Infinite.
Yeah. So yeah, so what is happening here? Why it is going to infinite loop? So what is happening if I is 6, then what is happening? The loop is going to infinite loop. Although, see, that is what I was checking. Here, I have like the conditions are well defined, right? So we need to run it till length of numbers, which is equal to 10. And what I am doing, I am incrementing the loop counter, right? Now, when I equal to 6, then what is happening? It is continuing. It is
Infinite.
it is continuing that same condition, right? Because this increment is this I plus 1, that increment is below that condition. So when at I equal to 6, so it is continuing the same loop, at the same index. Okay,
Yes.
so that's why it got trapped in the infinite loop. So if we use the break, so these are the distinctions. If we use the break, then it will come out of the loop. If we use the pass statement, then it will do nothing, right? It will do nothing. It will just pass that particular loop index. And also pass can be used outside the loop. If we use continue, then also its purpose is similar. So it will skip the loop index. Here what happened, as I have given the counter below that, so I equal to, when I become 6, then what happens, it is the purpose of continue is that skip that counter and skip that particular index and go to the next counter, but that is not happening here because my loop increment is after continue, right? So it is not able to come out of this continue and to go to the next counter because I is not incrementing here. Whenever I is becoming 6, then due to this continue statement, it is skipping but not able to increment the counter.
So
Okay,
it's skipping increment.
it is skipping the increment.
And
It is
again,
not
I
it is not reaching the increment itself.
yeah. Okay, got it.
Got it, right? Because my increment is after continue. So these are very important. My increment is after continue. So it is not reaching the increment itself. What it is doing, so it got stuck in continue. So it is skipping. So my print statement is before this continue statement, right? So so when I reached at 6, so it printed 6, and then when I equal to 6, then I need to skip that iteration. So it skipped, but it could not reach to I plus equal to 1. It could not increment I. So see, whenever a Jupyter notebook gets like it gets crashed or got stuck in infinite loops, then you can stop it from here, right? So you can select it and then you can shut down the particular. Anyway, so are the three statements clear? Break, continue, and pass. Hello.
Hello. I'm saying we can also stop using this stop button after run Jupyter Notebook.
Yeah, we can do that, but sometimes that doesn't work. So sometimes the notebook get hanged and this. So then in that case, you can select it from here and then you can shut down that particular kernel.
Okay.
First, you can try here when it is running, but sometimes what happens, like
It get hanged.
it get hanged. Then you can go to the Jupyter home and select, and then you can stop.
Okay.
So like that, you can select that and shut.
Got it.
I think I need to restart. Just be there.
Yeah, sure.
This happens sometimes. Okay, so start now.
Yeah.
So here is another example for continue, right? So as I explained, pass we have seen, right? So this example I have shown. So okay, so this example also we can see for pass. Okay, so here what we are going to do, remove all alphabetical strings, right? So the strings which are alphabets. So we want to remove all which the strings which contains alphabets. So as you can see, it is a here we have defined a string list. So some are numerical strings. All of them are strings only. Even the numbers also are stored as strings, but we want to remove alphabetical strings. So what I'm doing, so that I am iterating over the string list, and if string list dot is alpha, so this is a string method, right? So if we define a string, so similar to other data types, there are different methods, right? So that can be applicable to a string. Right. So it checks if it is alphabetical string. So if the string is alphabetical, then what we are doing, we are not doing anything. We are just passing it. Else, if it is non-alphabetical, then we are appending it to the string list. That is what we are doing.
Yes.
So this is the so string list is alpha that checks like if the particular string uh,
Okay.
is alphabetical. Not only character also it will or if it is alphabetical,
Yes.
right? So like ABC, this is an alphabetical string. A is an alphabetical string, right? So but this is not, because this is A1 to 3. This is not fully alphabetical. That is rather it is alphanumeric, right?
Yes.
So these are string methods. So see here how the pass statement comes into picture. So if the particular what we are doing, so I have created a new list, and whenever it is non-alphabetical, then I am appending it to the new list. Now, if the string is alphabetical, then I am just passing the string. Otherwise, I am appending. Right.
Yeah.
So now one more example with the continue statement. So here this is the string, right? So the string itself is string. So if value equal to I, then continue print value, right? So this is the difference. Earlier it went to the infinite loop, because after the continue I had used a while statement, right? So in while loop, after the continue, it could not come out of the continue statement to increment the loop counter. But in this case, I have used a for loop, right? So as you know, in for loop, the loop counter initialization, condition checking, and increment all happens in one statement, right? So here, what is happening? So I am iterating through this string. Now, if the value is means each character of the string, if the value is I, then I am continuing. Continuing means I am just keeping it, right?
Yeah.
And other things I am printing. So it printed str when it found I, then it just skipped that particular iteration, and then it continued with the remaining iteration. That means n and g.
Yes.
Okay, so these are the examples on the flow structure. So we have seen the conditional statements, and then we have seen the loops, right? So the different forms of loops: for loop, while loop, and break, continue, and pass statements. So pass, as I said, so pass is a generic statement. It's not necessary that break and continue we can only apply with loop, but it's not the case with continue pass.
Yes.
Sorry. So now I think you know about Python function creation, right? So I will not go into the details. So you know how to create functions, right?
Yes.
So some examples like uh, the function, while creation of function, we need to start with def, define. So that is known as function definition. Then we name the function, and then we will have function arguments, right? So we need to give the arguments of the function. So some arguments can take default values. Like I have defined a count string function here. So to count the strings in a function, right? So some arguments can take default values, right? So you can give the default values like here. This is a count str function. So base str you can give none, checklist none. So here I have given these default values. And if you do not give default values, then at the time of calling the function, you must need to pass the value. So do you need any example on function definition, or you are okay?
Yeah, I'm okay.
These are basic concepts, so I don't think because as you are already hands-on with Python, it's not required. And also one important concept in function. So I hope you know about Python lambda functions.
Yes.
Right? So it is also known as anonymous function. When we want to define a function quickly, right? So a short function, then we can define using a lambda function, right? So lambda is anonymous function. So we can define a lambda function. So the function by itself has no name. Like we can define the lambda function like that. Okay, so the function by itself has no name. It just starts with the lambda, right? So that's how we define the lambda function. When it is a one-line function or very short function, generally this lambda function concept we use uh, in case of when we apply or apply map, this sort of uh, things methods we
Oh,
apply with data frame, right?
yeah.
So these are known as lambda functions. These are like quick functions, short functions, and these are anonymous functions, right? So we do not need to follow the traditional definition of lambda in case of lambda functions, right? So just to have a quick look. So these lambda functions start with the lambda keyword, right? So this is defined like that: lambda arguments and then expression. For example, double equal to lambda x. So double is the name of. So double is the actually we are naming an object, and this object itself will store the values of the function, right? So this is how we can define, and then we can call this function. This is a lambda function. We can call this function like that. This is the name of so the point to be noted here is that in case of lambda function, like this is a quick function, so we do not need to follow the generic function definition, right? The standard function definition. Rather, we can define the function in one line. We can save the output of the function directly. Okay. Okay, fine. So we have covered these things, the basics of Python, the data types, then conditional statements. When it's basically conditional statement and loops, so those comes in flow structure, right? Control flow, and we have seen some examples. So now we will start with Python data frames. Okay.
Okay.
So we'll check first different ways of creating data frames, how we can create a data frames in different manners, and some operations on data frame. And then we'll see some examples like how we can read a data frame from CSV Excel files, how we can save a data frame, right? So these operations, how we can slice a data frame. So these operations we'll see.
Yes.
Okay, so data frames, like data frames is the concept of data frame is like one of the most widely used concept in Python, right? So data frame is very widely used, and its utility is quite widespread, right? So in many analysis, we need to use data frame, right? And uh, all the, like, when we talk about machine learning activities, or any sort of advanced analysis with Python, whenever we do, so we need to use data frame, right? So data frames by itself we can define a data frame as a structured data format which consists of rows and columns, right? So whenever we can express an information in the form of a structured way, right? So it contains the rows and columns. Then we can create and store the information in a data frame, right? There are other structure also, like we can use a 2D matrix, right? So in matrix also we can create information, but as we know, so matrix by themselves, so these are like unindexed. By unindexed, we mean in matrix we cannot give column names and row names, right? And we cannot sort of use the slicing and other operations what we can perform in case of data frame, right? So data frame is a generic structure in Python, and we use it from many places, right? So data frames creation and operations, data frames are performed through Pandas, right? So it is already included, and it is a when developing a module code, so it is better to include all the needed libraries in the beginning, right? The way I have done. So whatever libraries you require, so you can include them in the beginning. So we'll start with data frame creation. So here I have defined four list, right? Name list, age list, gender list, and experience list, right? Of some persons. Now I want to create a data frame. So see, one thing is that data frame can be created from a dictionary as well as from a list, right? And it is a generic concept. So there are multiple ways of creation of data frame. So here what I am doing, so name list, age list, gender list, and experience list, so these are four lists. So I want to create a data frame with these columns, these four columns, right? So uh, this is how we can create. So if you want to see the help on data frames, so again, so you can get the help like that, shift tab, right? So the signature of the function and the parameters, right? So it should contain data, index, column names, d type. So these things should be there. So data frame has these arguments. So here let me create this data frame. So what we have done, we have defined these four lists, and then I have created a data frame directly from the dictionary. So data, I passed this dictionary, and I have also given the names of the columns. So this data part, if you see, this is a dictionary, right? So name list contains the name list, what is defined. Age list contains the age list. So from this dictionary, I created a data frame. So keep one thing in mind: data frame and dictionary are quite closely related, right? So if we have a dictionary where each of the key value pairs are of same length, right? Then we can directly create a data frame from that dictionary.
Yeah.
Now, this is another way. So here what I'm doing, I'm zipping the four lists together in a list, right? And then I'm creating a data frame.
Yeah.
Okay, so this zip also I can do. So I am zipping the four lists together. So if I zip them, then it will take the same name as the names of the list, right? the column names will be same as the names of the list. And display, so this display command, display you can use in Jupyter Notebook for displaying the data frame. So this is a IPython command, IPython function. So display is for displaying the data frame or similar objects.
Similar object in sense?
Suppose you have a series or matrix, right? So mostly it is used for data frame only, but suppose you have a matrix, you want to view it, right? So you can use
But
display. But
but if we are not using display also, then also it will give. I mean, it will show
yeah, it will show. So display is for like
map.
uh, displays like it is a sort of customized command, right? So you can it is for seeing the data frame in a customized way, right? So this is for you are right, we can use display, or even like we can use print also, right? But suppose you have a large data frame, right, and you want to do some slicing and check parts of it, then display comes agent. Even you can use print also, so print will print the data frame in a plain manner, right? So these things are there. But generally, when we are working in Jupyter Notebook, then we use display. And another use of that is that suppose you defined different data frames, right? In the same cell, you use different data frames. Then, like you need to use either print command or display command to display the data frames created at each part. Is it clear or?
You know, clear only. But the thing is, like, if we are not giving any print or display, then
Mhm.
also it will give this table, right?
Yeah, it will give. You are right, but the point what I am making here is that suppose this will become. I hope this will become clear from here. So see in the same cell, right? So see the use of display. One thing is that it displays the data frame in a customized manner, right? So if we have a large data frame and we are doing some operations in it, suppose we want to see the heads of the data frame or some parts of the data frame, right? So display is always like a better command. You are right. If we are just we are willing to see one data frame, then we can see it just by writing the name of the data frame and then executing it. It will give the data frame, right? But display is more customized option. That is one thing. Second thing is that see here. So here in the same cell, right? I am seeing I have defined the data frame df1, right here, and now in line number 13, 14, I have defined the data frame again in a different manner, right? So now, so suppose this is df2, right? Now what will happen if I run it?
DF2 print.
Yeah, but I should have get df1 also, right? In line number 11, because this also I have defined, right?
Yeah.
But did it display df1?
No.
No. So see, so this is the reason. If we have multiple data frames we have defined in the same cell, suppose we are building a function and we want to we are building a function or a big chunk of code, and we created different data frames at different place, right? And we want to give the user the option of intermediate display also, right? So in that case we need to use this display. Then it will show the wherever you are using display and which part of the code it will display at that point itself.
Yeah, got it.
Got the usefulness, right?
Yeah.
Otherwise, if we are defining simply at one particular cell, one data frame, then what you are telling, then of course, like just by typing the name, it will give the data frame, it will display. But if we have defined multiple data frames in the same cell, then we need to explicitly write display to display the data frame. Otherwise, it will only display the last one.
Yeah, yeah, got it, got it.
Yeah. And print also we can use, but print will sort of like it will display plain data frame,
Mm-hmm.
not display the columns. Okay, so this is also this a method of defining the data frames, and in this case, if we do not give the column names, then it will simply uh, take the column names as 0, 1, 2, 3, right? Means the particular indices of the columns will be displayed. So if you want to explicit column names, then there is an argument columns, so that we can use, right? So this is a way of creating data frame.
Yeah.
Similarly, together with column, we can give indices also. So column is for name of the column. Indices are for names of the rows. So Python supports row namings also. So this is also an argument. So in data frame, we can give the column names, and also you can give the row names. So by default, again, row names will be the row numbers. Like here in cell number 22. So I have created a data frame. So column names, if I do not give, then as I was showing, so those will be zero, starting with zero till the length of the columns. Similarly, row names also by default they will be 0 to 4, right? 0 to n, the number of rows. So if you want to change the row indices also, then you can use the index argument, and you can give the specific index. And remember one thing, in Python data frames, the column names and row names are very important. Right? So row indices are used to do sort of like slicing, subsetting, then merging. So in all these operations, need to provide the specific row indices. So we can extract the particular column and row using the indices.
Yeah.
That thing is very important. So another thing here, so I have defined a dictionary here. So these are like different ways of creation of data frames. So I have defined a dictionary here again in that manner. So raw data is nothing but an explicit dictionary. As I said, data frame and dictionary are very closely related. You can directly create a data frame from a dictionary. So now I have created a data frame like that, and in place of columns, I have given the raw data. So this is the dictionary here, and the keys of the raw data. So those will be nothing but first name, last name, like that, right? So also I can create the data frame. And while extracting, fetching the data frame info, so we can different columns of the data frame. So what you can do, uh, like I have created this data frame, so df3. So then different columns can be extracted like that. So suppose first name, like that. So there is another similar object in Python that is called series, right? So this one is series. So series, it is like it is a plain data object. So it will have indices, and so series is not a data frame. It contains a single column, right? So if we extract the data frame, one data frame column like that, so it will be extracted as a series. But if we want this particular column to be extracted in the form of a data frame, then we can do like that. This particular column we can extract using the double this two double brackets, right? So similarly, we can use we can extract multiple columns.
Yeah. Okay.
Right? But if you do not give this error, then it will be a key error, right? If you want to extract multiple columns, see the difference. If we want to extract only one column, and if we do not give the inside double bracket, then it will be extracted as a series. But if you want to extract multiple columns, then and if you do not give the inside double bracket, then it will be a syntax error, right? Syntactic error. So this is how we can extract the infos from the data frame, the columns from the data frame. Now we'll see some operations on the data frame after creating a data frame. Okay, so before that, One important thing. So swallow copy and deep copy. The deep that concept is it clear to you?
Yeah, it's clear for me. It's okay if you skip that.
Okay. So just for my knowledge, can you tell me like why you use deep copy? Like what is the purpose?
Like we are using deep copy when we don't want changes in new list to affect previous list. So say if we are modifying any list, it should not affect previous list. Otherwise, if we are using the same list, because address will be same only. So whatever modification we are doing in the new list, it will like that modification will be getting affected in previous list.
Mm. Right.
So using copy, we can avoid that. So we can prevent any modification that we don't want for the previous list.
Yes. So this copy concept is used. Deep copy concept is used for injecting the reference frame, right? The reference data frame. So any changes after deep copying. So any changes, not only data frame. That concept is used for dictionary and other things. So whenever you use deep copy, then our reference, that is beige object, will remain intact. Otherwise, if we do any changes on the new object, then it will affect the beige object also. So this is one sort of little bit peculiar behavior in Python. But in other cases, other languages in C, C++, or R, if we define an object and then if we reassign the object to another object, then any changes on the new object will not affect the original object. But in Python, this is not the case. A reference is maintained with the objects, right? So to avoid this unintentional changes, we use the concept of deep copy. Okay, so now let us see some operations. So we have defined this df. So now let us see some operations. So find all columns containing name, right? So this is a query on the columns, right? So these things we will again see like again and again, as and when we will do modeling exercises and all. But these are some basic things we are covering for data frame, right? So all columns containing name, right? So there are many actually data frame methods. So I'm showing some of them. So see, this is my df4, right? So after having a data frame, so as you know, we can see the shape of the data frame using the shape command. Shape means row and column, right? The number of rows and number of columns. Well, we can also see uh, same cell. We can see the info of a data frame, right? So info will give the info about the columns and also the how many the memory used by the data frame, right?
Yeah.
So I'll quickly run this command. Then df3, we can also get d types. Right? So d types gives the data types of each of the columns, right? So my df is 4 columns, so it will df3 will dot d types will give the data types of each of the columns. So you can see that these are the columns. So this is my data frame. So it has 4 columns, 5 columns. Sorry, first name, last name, age, then child, male, female, and avail subsidy. So it will give the type of each of the columns, right? So here Others are typed as object. Only age is integer, right? Age is integer, and evil subsidy is a boolean column. So this is my data frame, right? So using D types, we can get the type of the data frame. Also, like data frame columns, they can be of any type. But one thing to remember is that each column should contain only one type of object. That it cannot contain mixed of objects. So either it should be a string uh, or integer or boolean, or even it can be tuple also. For example, child underscore mf. So it is a tuple, right?
Yeah.
Then another thing we can check. Okay.
One question. Like for age, it says integer 64, but for like first name, last name, it say object. Why not string?
Yeah. So see, in Python, object is not only first name, last name. Even for child mf also, it is showing as object, right?
Mm,
So in general, like if the type of the column is string, or it contains tuples or list, the elements of a column itself can be lists, right? Suppose you want each column contains each cell contains multiple information, those are clubbed inside a list. So these things will be displayed as object. So object is a generic data type, right?
okay.
Even if it is string, but the data type by itself is object. Even, and also another thing is that if you see the last name, so last name, the third one, that is the index 2, contains a null value, right?
Yeah.
So this last name is empty. Uh, so that's why even if it is a string, but it contains empty objects also, right? So that's why, like, to cover all these scenarios, the generic data type object is used.
Okay, so in a case if age also, if there is some missing value, so it will be object.
Yeah,
Okay.
missing value, if it is non-integer type missing value, then it will be object.
Okay.
So value counts is another command. So you can see the frequency of each of the objects in a data frame, in a particular column of a data frame. Frequency of each values. So here, but see, you cannot use value counts in a column of a data frame. Rather, this value counts is not an object of a data frame. It is a method of a series. So if I give so these things we need to keep in mind. Then if I want to use value counts in a data frame object, then it will be an error, because value counts is not a method of a data frame, right? Rather, it is a method of a series. So what it means? That means that this value count by itself, some commands are there are in fact various methods or attributes which can be applied directly to a data frame, like this one, shape, info, d types. But value counts and some other similar methods can be applied to a series. That means you can apply them to a particular column of a data frame. So it gives the frequency of each of the values in the data frame. So you can see like in Pandas data frame. So you can see like there are many attributes because data frame as it is very widely used concept. So there are various methods or attributes of a data frame, right? So these are the attributes. That means you can use each of these attributes are nothing but function, but these are specific to data frames. So you can use this each of these attributes to a data frame. Okay. So these are attributes, and methods means you can use these methods as a function, right? So if you define the data frame, then this absolute, so this will give the absolute uh, values of each of the entries, right?
Yeah.
Okay, so now I want to find, so another thing is that, so to find the columns of a data frame, so I defined this data frame. So to find the columns of a data frame, you can use columns. So you can see like there are many, I'm just showing some of the uh, attributes, but there are attributes for a data frame. So these columns attribute you can use, it will give you the names of the columns. You can also use list of df3, right? So list of a data frame. So by using so difference between attribute and method is that attribute is applied using a dot. These are very similar, and a method is applied uh, like a function on the particular data type, right?
Yeah.
Particular object. So list and then data frame, it will give the columns directly as a list.
Okay.
Okay. So these are some handy operations. Then you can see the index, that means the row indices, right? Then df.index, and then we can use to list. So it will give the indices as a list. So that was my data frame. These are the indices. So you can explore similar things. There are very simple but efficient commands for data. Now, here what we are going to do, find all columns containing name. So this is my data frame, and then tf4 dot columns, and then so I am using columns, then string ends with name, right? So str dot ends with name. So it will give you the names of all the columns which ends with name. So there are two columns, right? So this df4 dot columns, then str dot, so df4 dot columns dot str, so it converts the columns to string object, and then ends with, you can use ends with, starts with, so contains, so this attributes you can use with string.
So same functionality if I want to use for like rows,
Yes.
then how we will do that?
Yeah, so here I have applied in case of columns, right? So in case of row, suppose you want to check uh, which rows are say greater than equal to 5, right? So like the you want to slice the data frame such that row indices are greater than say 3 or 5. So you can use that option, row indices, row slicing option. You'll see some more examples. And this generally the row indices of a data frame are like numerical indices, right? So 0 to n. But as I have seen one example here, I have taken, so you can by yourself give a specific index, right? By default, the indices will be 0, 1, 2 till n. N is the number of rows. Then if you want to change the index, then you can give id1, id2 like that, or whatever the index name you want to give, you can give. And then you can query in the same manner how I did for columns. You can, in the same manner, you can query on the indices.
Okay.
So I think so. So I think df2. Df, yeah. So now, so as you know, in Python, these operations are very like self-explanatory and logical. So first we can find the indices. Then we can uh, we can transform the indices to a string object. Then you can check. See, these are the options like ends with, starts with, right? So starts with id, right? So in this case, all of them starts with id, right? So that's why it is returning all of them. But in the similar manner, your question was the same thing. Can you apply in case of row also? Then the answer is yes. So is this understood?
No, actually, my question was in values, like not in rows and columns, but in values. If I have to, I mean, say if John, what
Hmm.
are the records where John is there? Like value is John. So
Hmm.
how we can filter out those records, like complete records?
Oh, okay, okay. You are telling the cell values.
Yeah.
Okay. So in the same manner, so there like you can slice a data frame. So using the condition that will be seeing in the subsequent example. Here I have shown you how to do the column slicing and
Okay.
row slicing, right?
Yeah,
So
yeah.
in subsequent examples, we'll see how we can. I got it. So how to
I have
subset
this
on the
one.
basis of values, right?
Yeah. Is in this one. This one. My question was
Hmm.
is in.
Yeah. So yeah, so for subsetting the values, so df4, suppose I want all the first name which are in these three, right? So df4 first name is in dot is in. So see, is in is a, again it is an attribute of a series, right? So if I give, so as I was explaining, so these things are like need to understand very minutely. So df4 first name, right? So if I extract it as a series, then I can use egin. So egin a method of the attribute of the of a series.
Okay.
So I want all the I want to subset the data frames as that my first names are in these three values, and another conditions also I can other conditions also I can give. My age is greater than equal to 25, right?
Yeah. But we can't find like from whole data frame.
We can.
Like if like from a complete data frame we can't. Okay. Okay. No. No. It's fine.
Mm, see, okay, but
Actually, somewhere in the interview question, he asked me like in data frame, like for particular, like not particular, like for particular matching string, how you will get records for that particular value from the whole data frame. So I mean, isn't we will use, right?
yes, yeah. So see, so you can okay, so
I'm not sure like whether he was saying that you can use the particular column or like it was like from complete data frame we have to match the condition and then it should give the records. But then
uh,
also some column needs to be matched. Like
okay.
so I
So I
did
think you are asking this one. So correct me if I'm wrong. I'm trying to understand. So okay, so here, like you need to know the column name and the type of the column, right? So here my first name is a string column, right? The type of the column is object. It contains string values. So I'm using isin. Now, if your question is, we do not know where the name say JSON occurs in the data frame,
yeah.
right? So in that case, we can simply use this one, right? df4 equal to JSON. Suppose I want to find where the ingestion occurs. So you can directly use this. Then you can see that all other places it is false. First name, that means in this place it becomes true.
Okay.
Uh, so in that manner, you can find. Suppose you want to see where these
I
names.
think that first one only isn't only was he was asking.
So
But
this I am showing if suppose you want to search only one key, right? So here Jack, at what place it is occurring in the data frame. But suppose you want to see which places these three values are occurring, right? So then you can use easy.
yeah,
But suppose you just want to see like where Jake is occurring, means one particular value is occurring, then you can simply write data frame equal to that value. Then where it is true, then that index will be returned.
okay, got it.
Okay. So like that, right?
Yeah,
Okay. So I guess this is clear, right?
yeah,
So we'll see some more similar operations. So these are some methods. So you understand now the difference between method and attribute, right? They are very similar. Attribute is applied after dot. It is a function that is, because as you know, one beautiful thing with Python is that we can apply multiple operation in a chain format, right, using dot, right? So after any data, any object, after dot we apply the attribute, and method is a function that is applicable to that particular object, right?
yeah.
So some more things. So print any, right? If I want to check, so any and all are two methods. So any checks like if any in any cell the condition is true, and all checks if in all cases the condition is true. So I am checking if all df4 dot age, right? Another thing is here, if you know the column name, right? So I have my df4, so this is my df4. Then if you know the column name, then you can directly fetch the columns using dot. So column themselves, each column themselves you can use, you can extract similar to an attribute. So like age, right? So it will extract age as a series, right? So you can use the single double bracket, or you can directly extract like that. So these are any and all. So any, it checks if any value satisfies the condition. All checks if all satisfy the condition. So then some other operations. So like these are just some example operations. Like you can take the square root of a data frame, find the max values, mean values, unique values of a data frame, right? So you can take. Okay, so do you have some time? So I will start with the exploratory data analysis part. So I will start with uh, basic things first, like how to read your data from Excel CSV, how to do some operation and then write it back, right? So those things I will start. So can you continue for some more time?
Yeah, yeah, sure.
Okay, so give me 5 minutes. You can also take some break, maybe take some water. So we will start after 5 minutes.
Oh, okay. By 8:15 it will be over, right?
Yeah, yeah. By 8 o'clock, 8:10, it will go.
Oh,
8:10, 8:15.
okay, okay.
Hello.
Hello.
We can continue now.
Yeah.
Okay. So now we'll see how to read a data frame, read and write a data frame from external drive, external location. So this is how we can. So if the data frame itself is in our code path, then we can simply read the data frame using the name of the file. Suppose this is my code path, right? So keep a data frame here. Okay. So for reading, so Python has excellent support for reading and writing CSV and Excel files. So we can use read CSV. So again, so you can see the signature of the function. So read CSV is for reading CSV files. So so this is how we can read using pd.readcsv. You can save it in a data frame. It should be .csv, right? So here we do not need to give the path name because the file itself is in our working directory. Then we can, if that is the case, uh, then we can directly give the file name, right? So here the file itself, so I am executing Jupyter Notebook from this folder, codes folder. So I kept the data frame in the code folder. So you can directly give the name of the file and it will read the file. And then we can use df.head. So it will give the head of the data frame. Tail will give the tail of the data frame. And other things also we can use, right? So df.info, as I was showing. So we can see the info, right? Info of each of the columns and also the usage, memory usage. It will give the, so you can get an idea how big the data frame is.
Yeah.
So and you can use d types. So it will give the column info of the data frame. So those things you can do. So now let us see. Suppose this operations are very useful when we are writing a big full-fledged code. So how to read write data frame from different locations. Now suppose my data frame is in a different location. So this is my data frame. This is the location of my data frame. Okay. Okay. Now in this location, there are multiple data sets. Right? So this is the location, right? So suppose I want to read this data frame. This is already built data frame. Uh, this is an Excel file. It is 2 sheets. Right? I want to read this data frame. Then, so this file path is my generic path. So my base path, standard path. Then I give file name. I want to read say psnet1 dot xlsx, right? So then I can use this. So this is an Excel file, right? So in PD, in Pandas, we have read Excel.
Yes.
So read Excel, and then we need to create the file name, right? File path and file name. We need to create the file path, right? So in Python, we have an option of creating the file path. So file path from objects. For that, we need to OS. So then uh, we can create a file path like that. Right. So see os.path.join. So it will create the entire file path. So this is my file path, and I want this particular file, right? So I used os.path.join. Now I want this file, right? And this is an Excel file. So now in this file there are two sheets. So suppose I want to read the data sheet. So my df is read. So this is my df. Okay.
Yeah.
So what if I want to read the entire Excel, right? All the sheets of the Excel. So do you know how we can do that?
In this we can get
In, how can we read the entire? So I have that's why I have kept another example of one of my live projects. So it has multiple sheets. It is an Excel file. It has multiple sheets, right?
yeah.
All these sheets. So
Iterate. We can iterate like sheet names. You like we can put in the list and then sheet name we can iterate.
right, we can do that. Yeah, of course, we can iterate over the sheet names. So first of all, we need to find the sheet names, right?
Yeah.
So after finding the sheet names, we can iterate over it. But Python is a very simple framework for that. Don't need to do anything. Just so I want to read this data frame. So what we need to give in place of sheet name, we can give simply none, right? Then what it will do? Uh, what it will do?
Oh,
So it
single
will,
file will come.
yeah.
Sheet.
So it will read the entire Excel file, the each of the sheets as a dictionary, key value pair of the dictionary. So just check this. So now this dset dictionary. So you just need to give sheet name equal to none. So this is the dictionary, right? So if you see dictionary or keys, so these are the keys of the dictionary. So this many sheets are there.
Okay.
Coefficients, illustration. So it's very simple, right? So you just need to give sheet name equal to none. Then it will read all the sheets and it will keep the sheets and the respective data frames in the dictionary keys. Now you can fetch each of the elements of the dictionary. So d set dictionary. Suppose driver coefficients, right? So this is the driver coefficients. So each of the sheets read as a dictionary, part of the dictionary, right? So one dictionary that has the keys. Keys are the names of the sheets, or rather names of the tabs of the Excel file, and the contents, the values are the respective data frames. So this is how we can read multiple uh, sheets in one go. So this is a very useful operation. So the read Excel and write Excel, so those are like very useful operations, right? So and very powerful. So there are a lot of options there. And even like at the time of reading, suppose we have a when we work with big data, so suppose your data frame itself is quite large, but
Yeah.
you don't want to, not all the columns are needed. So at the time of reading from the Excel file, there is an option of giving the column names. So not all columns will be read, only the respective columns will be read. So
And sometimes there is problem like when data is very large, like it will not read. I mean, it takes so much time to read, to load data.
yeah. So there is an option of reading the data in chunks, right? So
Chunks.
when we work on live projects, so a number of times our data is very huge, right? So instead of reading the entire data in one go, suppose millions of rows and some say 1,000 columns, right? Suppose 10 million rows and 1,000 columns. So of course this data set reading, so we often like we encounter these problems. So if we go on like using simple read Excel, then the entire what it will do, it will try to read the data frame in one go, right? So it is very much time consuming, right? So there is an option of reading a data frame in chunks, right? Instead of reading the entire data frame, it in one go it will read the data frame chunk by chunk, right? So maybe I can show you one example in the next class how we can read a data frame in chunk.
Yeah, sure.
So now here uh, showing you this option again. I'm reading this data frame, the previous T set one, but this time I don't want to read all the columns, right? So this also sometimes like we face this challenge also. So not all the columns are needed, right? So it has actually total 101 columns, right? So I created this dummy data frame for, for one of my session. So I just want suppose these 4 columns, right?
Yeah.
So at the time of reading itself, so there is an option of, as you can see, huge columns. So this argument is there, huge columns, right?
Yeah.
You can use that huge column option. So I want the sheet name data, and then use huge columns. So huge column should be a list like that. These are the column names I require. Right?
Yeah.
So now I have read my data. So you can see that it only read the 4 columns. So these are very simple things, but like you should know, right? So otherwise, like sometimes we break our head, like how we can achieve this. So this data frame has actually hundreds of columns, but we do not require all of them. So many times when we work on a machine learning project, so not all the columns are necessary. So why to read them in the first place, right? So we can use huge columns to like just only read the needed
Columns.
columns, right? So that is one thing. Of course, like we will do the other things in EDA in the next session, subsequent sessions, like missing value outliers. So now I'll conclude today's session just by showing you how to write a data frame, right?
Yeah.
Saving a data frame in Excel. So we have three data frames. So let me read the entire data as a dictionary. Sheet name I am giving as none. So it will read all the sheet. So it is read both the sheets. Right? So now I want to write the data. Suppose I did some operations. So now I want to write it in the Excel file. So this is how we can do that. pd.excel writer, right? So pd.excel writer. So this is the engine to write an Excel file, and in the same Excel file, either one or multiple sheets we can write in the same Excel file. So pd.excel writer is there. So I want to write it on dset 4, right? The data frame. So here, like I'm just showing you how to write. So just please see it carefully. So I have not done any other operations, but often like after reading a data frame, of course, we will do some slicing and some like, of course, some EDA analysis and operations. Then we
Yes,
can
yes. Is
write.
lots like there is lot of requirement like this, like where we have to do the functionality. But we
Mhm.
often use OpenPyXL because sometimes analyst wants like coloring and much more stuff,
Yes, yes.
colors
So
highlighted, and so for that purpose, I think OpenPyXL is quite better.
yes, so that also you can use. So this one is handy, like if just you want to save them as like in multiple sheets, right?
Yeah,
So there are other options as well.
even for appending the data, like while scrapping, like say if my code is running for 1 hour, and so because of so this happens many times, so we are like appending, like writing the data while scrapping only. So it is like after 1 hour, suppose some error is there, then also we will not lose the complete data. It will be like, okay, 50 data points will be there with you, because after 50 data points some error is there, then it is like every
It will
time.
save till that point,
Yeah,
right?
because otherwise it will be like whole 1 hour gone, and you will have no data. So
Yes.
that time it's important.
Another option is that, like I always recommend that, we can use pickle. So we can save the dictionary as pickle files. So whenever you did some operation, so before even before writing as an Excel file, so in almost all the projects I have worked, right? So we save the object as pickle file. So what is the purpose of the pickle file? So have you used the pickle concept?
Not used in the projects.
Okay, so a pickle file will retain your data like structure, and it will have the as it is format. So suppose here my data set is a dictionary, right? DF dictionary.
Yeah.
So that is how I saved it. I have read it, right? So this is my dictionary,
Yeah.
and it contains my data and everything. And suppose I did a number of operations on this on the data frames, and then this is my final dictionary. Then I can save this entire dictionary as a pickle file. Then what it will happen, it will sometimes what happens, suppose the data frame contains some date columns and other, so you did some date manipulation, right? So date columns cannot be directly used, so we need to parse the dates in Python.
Yes.
So after date parsing and everything, so you are saving the data frame in Excel. Sometimes there are multiple things. One thing is that if your data frame is very big, then writing the data frame itself, it takes large amount of time, right?
Yeah.
And another thing is that if you have done some column formatting and all, suppose date parsing and all, so after doing that, if you are saving the as an Excel file,
Yes.
then those formatting will be lost, because Excel will save the columns as like plain columns. Then again, after reading the data frame, you need to do the column formatting.
Yes.
So a better option is to save the entire object as a pickle file. Then you will not lose the contents of your data.
Okay, can you, I mean, in next session, give a demo for the same, like save as a pickle?
Yes, yes. This is actually very useful. So, the similar concept we use in R also. So in R we save as R object. In Python we save as a pickle file. So just you need to whenever you need to showcase, suppose the results to business person, so you can save the Excel file. But many times, like we have a say very big dictionary containing multiple data frames, right? So and we did a lot of analysis, so then we can simply save the data frame after doing the analysis as a pickle file.
Yeah, good. Got it.
So it will retain the structure of the data, because you also, I think you might have observed that sometimes, like when we save it in Excel file, then the column formattings are lost.
Yes, so many times.
Yeah. So yeah, so in that case, like it is better to save it as pickle. Maybe I can show you from one of my
Um,
project.
it's okay if in next session you show me.
Yeah, yeah. So not this means just how we can, like
Yeah.
how I used to save, not how to create the pickle files. That of course we will discuss in the next session. So yeah, so I did k-means clustering and dimensionality reduction. After that, the results I have saved as pickle file. So this is the I perform the k-means clustering, and then see save the k-means result in a dictionary, the pickle dictionary, right? So after clustering, so this is how I save. So by doing so, my entire thing will be saved as an object. So it's just like I need to next time I need to call it, right? So
Got it.
this KM cluster, it contains a number of data frames, big data frames. After doing the clustering, cluster profiling, and all, so the entire thing I am saving as a pickle file. Right? So next time I do not need to perform all this analysis, right? Well, everything is done, and this is my final data frame. So I final dictionary. So I just need to call the dictionary, and if I want to save some part of the dictionary as Excel file, I can save it. Otherwise, the entire thing will remain intact as a pickle file. So okay, so in the next session we'll see these things, how to write and read from pickle files, and then we'll start with the exploratory data analysis (EDFs). Right? We will also see some parts of plotting also, how we can generate different plots like scatter plot, LM plot, line plot, different types of plots using Python, and then we'll start with the EDA parts, right? Missing value, outlier treatments, correlation analysis, sparsity, those things.
Okay. One more thing. Can you suggest me from where I like good a source where I can read statistics? I mean, which is required for data science.
Yeah, so I will suggest you, there are some good blogs as well as some books also, nice books, like you can refer, like data science books which have good contents of statistics, right? So it is not too much in details, mathematical details, but like they provide the different statistical concepts with the associated usefulness and codes. And in Coursera or Data Camp also, you can find like some good books on statistics from data science point of view.
Okay.
So I will share some links with you on the Google.
Sure. Okay.
Okay.
Thank you.
So our next class will be on Saturday.
Yeah.
Okay.
Okay.
Bye.
Bye. Thanks.